Okay guys, this is attempt number 2 at this lesson. Today we're going to be starting with a little bit more of our algebra unit. We're going to look at specifically patterns and identifying pattern rules. So just to kind of start us off with thinking our knowledge area, I want to draw out just a geometric shape. So I'm going to draw this, and these are all going to be green. And then I'm going to just do this on the side. I'm going to have 2 here. Actually, I'm going to have 1 there. I have 2 here. I'm going to have, it's going to be tight, 3 here. And I'm going to label these just really quickly. I'm going to label these figure 1, figure 2, and figure 3. So what I want to ask you is, what stays the same? So what is the thing that is not changing no matter what? That would be the green. You notice that there's 3 green in each one. And this green, the thing that stays the same, we're gonna know this in our algebraic expressions as the constant, okay? And we'll represent it in our algebraic expressions as so. And so therefore, when we look at the red, we see that the red is changing every time. And these reds will then be known as our variables in our expression. And we could look at this pattern, and you could look at it in a number of different ways. You could look at it and say how many total boxes are there in each figure, and how many total red ones there are in each figure. And you can create algebraic expressions about that. For this one, I want us to think about, okay, let's look at how many there are in each figure. So in figure 1, there is 3 and 2, which is 5. In figure 2, there's 3 and 4, which is 7. And in figure 3, there's 9. And if you just looked at this geometric pattern, you could probably be able to identify what would be the next 3. And so that's what I want to kind of talk about, is when we look at geometric patterns, we can kind of see a pattern growing, so, or in this case growing, but it could be both. So if we go from 5 to 7, we know that this is increasing by 2, and this is increasing by 2. And because we know what the increase is, or the pattern growth or decrease, we can continue to make assumptions about this pattern. So if we can say that the next 3 numbers would be 11, 13, and 15. And this is the basis of what we're going to be doing today when we talk about looking at a pattern and creating a pattern rule. So what this all is going to lead into is what we call, I'm just going to erase this quickly, is what we are going to call today, hopefully it doesn't stay like that forever, finding the nth term. Okay, and we call it the nth term because it's the pattern rule. So we're looking at creating an algebraic expression that would give us a rule for a growing or shrinking pattern. So let's create a scenario here. Let's do this. In the first figure, I'm going to give 6 dots. In the second figure, I'm going to give 9 dots. And the next one I'm going to give 12 dots. And in the fourth one I'm going to give 15 dots. Okay, so it's really important that we label these figures. So figure 1, figure 2, and I'm going to show you why in a second. So how are we going to find this pattern rule? And how can we write the nth term, or the nth rule? So the first step, and I've written it out here for you guys, the first step is to make a chart of the term number and term value. Okay, so make a chart of the term number and term value. So we're going to do that right now. So we're going to create a t-chart, and on one side we're going to write term number, and on the other side we're going to write term value. Okay, and that's what it kind of stands for. So the TV stands for the term value, and the TN stands for the term number. Now stick with me because this could get a little confusing if you don't really understand. The term number pretty much stands for where the pattern is or the number is in this whole thing. So the term number for this pattern is 1, okay? Because it's the first thing that we see in this growing pattern. So when we write our term number, we're not writing F1. We'll just write 1, 2, 3, 4, right? Because we have 4 figures in this. So term 1, the term number for 1 relates to this. The term number for 2 relates to this. Term number for 3 relates to this. And the term number for 4 relates to this. So when we create our term numbers, we just kind of have to label them like this. Our term value represents, okay, in the first figure, what's the value in that figure? What is the number associated with that figure? So in the first figure, the value is 6, right? There's 6 dots. So we write 6 here. In the second one, in the second term number, the value is 9 and 12 and then 15. So when we talk about term value, we're talking about what is the actual number in the pattern, whereas this is talking about what's the order of the numbers. Okay, and we'll go into a little bit deeper of this. I don't want you to get too confused right now because we're going to do so many examples today that you're going to kind of figure it out in the end. So step 1, create our term, make a chart of our term number. Step 2 is we have to look at the term value to uncover the pattern, either increasing or decreasing, okay? So look at the term value to uncover the pattern, increase or decrease. So we'll do that right now, okay? We're gonna look at this and we're gonna say, okay, we're not focusing on the term number, we're only focusing on the term value. How do you get from 6 to 9? Well, you're increasing by 3. How do you get from 9 to 12? Well, you're increasing by 3. How do you get from 12 to 15? You're increasing by 3. Because all of the increases are the same, they're all constant, we call this a linear equation or a linear pattern because each one is going up by 3. So we've identified that this term value, the term values are going up by 3. They're increasing by 3. This 3 represents our variable for our what's it called? Our pattern. So what we're going to do is we're going to say, okay, because I know that the pattern is going to increase by 3, I'm going to write 3n. I'm just using n as my variable just because I just want to represent it that way. So 3 represents the way that the amount that it's going up, and you're like, well, plus 3, this is multiplication. When you're doing repetitive addition, it's the same thing as multiplication. Okay, so because this was 3, this in front of the variable, that becomes a 3. If this was 5, then in front of the n, it would be 5. But let's stick with it for this is 3. Okay, we're going to go back to our rules of how to figure out the nth term. Step 3 is to try the pattern rule. Okay, we're going to try the pattern rule by doing the variable times the term number should equal the term value. Okay, so the variable times the term number should equal the term value. Okay, so right now you have no idea what that means. I'm going to show you really quickly. So we've decided that this is currently the pattern rule. Okay, 3n. So what we're going to do is we're actually going to try that out, and we're going to use the first term number. So instead of writing 3n, we're going to write 3 times 1. Okay, we're going to use this 1 here. And that should equal, if this is the correct term, if this is the correct term pattern rule, 3 times 1 should equal whatever's in the term value, which is 6. Whoops. Okay, it should equal 6. So let's do the math. 3 times 1 is 3. and then we have 6 down here. 3 does not equal 6, okay? So what if we reach a point like this, we know that this can't be the pattern rule. It's missing something, okay? So we're gonna go back to our list of things to do, and we're gonna come up with stage 4. Identify how to get from the pattern rule to the term value by adding or subtracting a constant. Okay. Oh, you can't really see that, sorry. Okay, by adding and subtracting a constant. What does that mean? Well, what I'm trying to say to you is look at this. How do you get from 3, which is our term number and our variable, our pattern rule, how do you get from 3 to 6? Well, to get from 3 to 6, I would have to add 3. This now becomes my constant in my pattern rule. So I'm going to take this and I'm going to bring it up here. And I'm going to add it to my pattern rule. So now it's actually going to be 3n plus 3. Now, I'm pretty confident with that. This is my actual pattern rule. This is the nth term. In order to figure that out, I'm going to have to then try it out again. I don't want to try it with number 1. I want to try it out with one of these other ones just to kind of verify. So let's try it out with number 3. So I'm going to rewrite this. I'm going to rewrite it over here. 3n plus 3 should equal 12, right? Oh, sorry, 3n plus 3. Now let's input this. The 12 is the third term number. So I'm going to replace the n, right? This can pretty much say tn. I'm going to replace the n with a 3 because it's the third term number. And I'm going to make sure I add my 3. It should equal 12, right? And what I'm trying to say here is that this 3 is associated with this 12. So if I'm putting the 3 here, I got to put the 12 on the other side. So now let's do the math. 3 times 3 is 9, plus 3 should equal 12. 9 plus 3 is 12, equals 12. Because I've gotten to that line, I know that this is the pattern rule. Now you're probably sitting there being like, I am so confused right now. And that's okay. This is the basis of, it's not easy to explain this concept, so we're going to do it again and again and again until you feel comfortable. Okay, so let's try another one. We did here a geometric pattern. We can also just simply do a number pattern. And so that's what we're going to do on this one. We're just going to pick numbers and we're just going to go with it that way. So let's say I had the pattern of 6, 11, 16, 21, and 26. Okay. Step 1, if we remember back to my list, step 1, let's make a chart of the term number and term value. So let's do that right now. I'm going to do it in the corner over here so we have a little bit more room to work. So we're going to have Tn and Tv. So Tn, again, how many numbers are in this? 1, 2, 3, 4, 5. So this is the first number, the second number, the third number, the fourth number, and the fifth number. And that's how I'm going to respond to them when I put them in my chart. So there's 5 numbers, so I'm going to go 1, 2, 3, 4, 5. Perfect. Okay. Now, the first number, well, that number is 6. I'm going to use a different color, sorry guys, just because it's a little bit easier for me to show. So 6, second number is 11, third number is 16, fourth number is 21, fifth number is 26. Right? That's all I did. I looked at the term number is what are they in the order. The term value is what number is next to that term number. What's the value of it? Okay, so that's all I've done. So I've created my chart. Excellent. Let's go to step 2. Step 2, look at the term value to uncover the pattern equal that is either growing or shrinking. So let's look at the term values. And I got to think about, okay, how am I getting from 6 to 11? Well, from 6 to 11, it is growing by 5. What about from 11 to 16? Well, it's growing by 5. It's growing by 5. It's growing by 5. It's going to be a linear pattern. Now, For the most part, guys, we're going to be talking about linear patterns. I'm going to teach you guys nonlinear patterns, which is more of a grade 9 thing, but I thought it would be good for you guys to leave with it. But for now, we're dealing with linear patterns. So we've identified 5. What did we say we needed to do? That 5 now becomes my variable, right? It becomes my variable's counterpart. I'm going to call it my sidekick, okay? So it's 5n. So I think that the pattern rule for this growing pattern, I think the pattern rule is 5n. So how can I test it? Well, step 3, we have to try the pattern rule and the variable versus the term value. So we're going to do that. We're going to take 5n and we're going to try it with this first term number. So what we're trying to say here is we're saying, okay, 5 times 1, right, the term number 1, should equal 6. Let's do the math. 5 times 1 is 5 equals 6. Okay, so this does not work, which means that this variable is missing a constant to make it a proper nth term rule. So what do I have to do? Remember, step 4, which I wrote a little bit too close to the bottom. Step 4 says identify how to get from the pattern rule to the term value. So I'm looking here and I'm saying, okay, how do I get from 5 to 6? Well, I've got to add 1. If I'm adding 1 here, then I'm adding 1 into my pattern rule, because I'm missing a constant. So I'm adding the constant over here. And now this pattern rule looks like it might work, but I need to test it out. So let's test it out with number 5, for instance, okay? So I'm going to rewrite it, and instead of writing 5n, I'm going to write 5 times 5, because I'm using the 5th term number, plus 1, right? Because I have to make sure that my entire pattern rule is here. Should equal, what's the 5th number? 26. It should equal 26. So now we do the math, okay? 5 times 5 is 25, plus 1. 25 plus 1 is 26. We know that this is now, this right here is the correct pattern rule to describe this growing pattern. So 5n plus 1 will describe this growing pattern. And the nice thing about this is the fact that because I know the pattern rule, I can figure out any number that would be in this pattern or any number that might not be in this pattern. So if I, for instance, asked you, what's the 11th term number, right? So if I asked you to tell me what the 11th number was, right? If we just kind of kept going, I could make a chart like this and just do it that way. Or I could simply do this. I could take my pattern rule, and instead of the n, I'll input 11. So I'll do 5 times 11 plus 1, and I'll figure out what that number equals. 5 times 11 is 55, plus 1 equals 56. Okay? So by figuring out the pattern rule, I can figure out any number that is in that pattern. Okay, let's try another one for knowledge. Let's do another one together. Let's do this one. I'm going to give you, in this one, I'm going to actually give you the chart. Okay, so here it is. So we have our term number and our term value. And I'm going to give you, there's going to be 3 term numbers in this. The first term number equals 2, the second term number equals 5, and the third term number equals 8. So let's talk through this. We've got our chart done. Next step is to look at what is the growing or shrinking pattern. Here, from 2 to 5, we're going to add by 3. From 5 to 8, we're going to add by 3. Now that I know that this is 3, I can very, very confidently say that the variable counterpart will be 3 next to the n. Okay, I think this is the pattern rule for this, 2, 5, 8. How do I check? Well, I have to try this out now. So I'm going to try it out with the first number. 3 times the first term number should give me 2. I can already see that this is going to be an issue. 3 times 1 is 3, and it does not equal 2. Oh, what do you notice here? You notice that in the previous ones, to get from this number, the term number, to this number, the term value, had to increase. Whereas here, what are we having to do? we're having to decrease, we're having to subtract. So to get from 3 to 2, I actually need to subtract 1. That's fine. Because I need to subtract 1 here, up here, when I write my term rule, it's going to be 3n minus 1. So I feel pretty confident now with this term rule. Let's try it out. I'm going to do it with the third number. So I'm going to take 3 times 3 minus 1, right? I can't forget this constant. Otherwise, the pattern rule doesn't make sense. It should equal 8. Let's try it out. Not 3 times 3 is 9. Minus 1 equals 8. 9 minus 1 equals 8. 8 equals 8. We are in a good spot. Okay, I'm going to actually get you to try one on your own, please, okay? I'm going to give you one that's a little bit challenging, but something that I think you can handle. Okay, so I'm just going to erase this. Actually, you know what? I'll give you a new board with it. So here is your growing pattern, and you're going to take it through all the steps. Okay, your growing pattern is -5, -1, and 3. Okay, so go through the steps of making your chart, finding out the pattern growth or decrease, create a pattern rule, try the pattern rule, add the constant if necessary, and then test for authenticity. Okay, go. Okay, so you are back. So you should have the first step made your chart, and it should have been your term number. Well, of course, this one doesn't work. It should have been your term number and your term values. And your first term number, you should have had 3 in the term number category, and you should have had the following numbers here. Term number is -5, -1, and 3. So I made this one for you guys because I wanted it to be a little bit challenging, but also something that was reasonable. So I only gave you 3 numbers. How do you get from -5 to -1? Well, you're adding 4, right? And how do you get from -1 to 3? You're adding 4. So because you added 4, what you should have done is you should have said, well, 4 is going to be my counterpart. So it's going to be, my pattern rule right now is 4n. And then at that point, you should have said to yourself, okay, I got to try this out. I'm going to try this out with the first one. So 4 times 1 should equal -5. Okay, 4 times 1 is 4. It definitely does not equal -5. So you would have asked yourself, how do I get from 4 to -5? I've got to do a lot of subtraction, right? So I have to take away the original 4 and then take away an additional 5, and I would get -9. So because I got -9 here, I would add the -9 here. So now my pattern rule reads 4n minus 9. At that point, you should have tested it out. And you should have read something like this. Okay, let's do the third one maybe. So 4 times 3 minus 9 should equal 3. 4 times 3 is 12. Minus 9 equals 3. 12 minus 9 is 3 equals 3. Well done. I want to pause you here to show you a little hint. Now, I'm showing you this process because it's important for you to know, and this hint sometimes confuses people. And so if it confuses you, don't use it. If it doesn't confuse you, it's a great addition. Right now, our term number starts at 1. And this is to find the constant. This is to do this part. So the hint I'm giving you is how to find if there's a constant in your term value, in your pattern rule. So imagine that I said that there was a term 0, okay? And this is gonna help you find out what your number would be. So if there was a term 0, you would do the opposite of what you were doing this way. So instead of going down by 4, you would subtract 4, right? So if I wanted to find out what term 0 was, I would subtract another 4. Well, -5 minus -4 is -9. Well, what do you notice about that? That is the number that you are going to, that's your constant that you discovered, which is what you're going to be adding into your term. So we are going to talk about the term the zero term number again when we get into some of the other areas, but I just wanted to talk about it now so you can kind of have an idea. So that currently is your knowledge section. If you are confused, go back and try it. Or if you are really, really confused, reach out to me, and I'm happy to maybe do some more ones with you, either live or give you some to practice on your own. But this is the nth term, or trying to find the pattern rule. That's the most complicated piece right now that we're going to be dealing with. Okay, so we're going to turn this off. We're going to come back. There's the application video below. I want you to go try that one out.